This question on the board, I decided to come with a calculator in order to simplify these. This can be solved without the use of calculator, but I brought this so as to make it very simple for the students out there preparing for WAEC, JAMB, or any exam. So I can teach them on how to make use of the buttons, the sign, cos, shift sign, and every other thing. Now on the board, we have a boat sails 6 kilometers from a port X on a bearing of 065 degree, and thereafter 13 kilometers on bearing of 136 degree on Y. Now, what is the distance and bearing of Z from X? On the board, you have a bearing question on the board. The bearing question on the board. Now, this bearing question, we're going to take it step by step in order for you to understand. I wouldn't want to breeze it. I want to take it step by step for you to understand, because mostly students find this very difficult, especially those sitting for WAEC and NECO. They find this very difficult to solve during exams. I'm going to make it simple. I'm going to simplify it, taking it step by step. First of all, let's do the first one. I said a boat sails 60 kilometers from a port X on a bearing of 065 degree. Now first of all, let's get this part first. Before making your bearings, you have to first get the 4 cardinal points. Your 4 cardinal points. And please, when placing your drawing, you don't start from the center or at the center of your paper. You always start by the side, because you don't know where it will be taking us to. So we start by the side of it. So where any place it takes us to, will go that direction. But when you start from the center, you might make a mistake. Now I started mine here. First, you get your 4 cardinal points. You get your north, your level, your south, west, and east. These are the 4 cardinal points. And now I said a boat sails 6 kilometers from a port X. Now this is our port X in which the boat is sailing from on a bearing of 65 degree. Now if you check our cardinal points, from north to east is 90 degree. From east to south, 90 degree, making it 180. From south to west is another 90 degree, 270. Then from west to the north again, making it 360 degree. And now they said the boat is coming out from this port X on a bearing of 65 degree. Now where do you think the 65 degree will be coming out from? Starting from the north. The 65 degree will be coming out from northeast. It will come out from what? The boat will come out from northeast using 65 degree. And we said that from here to here is 90 degree. Now from here to here is 90 degrees. 65 degree is in between north and east. So what we do, we said from here to here is our 65. Now we'll draw the boat. This is the boat coming out. We call here 65 degree. You see it down. We don't cover all to become 65 degree, because from here to the east is already 90 degree. So we just call here. You cut a little part, 65 degree. Then make it the rest 25 degree, which is 90 degree. Now this is the boat that came out from this port X with 65 degree. And moving, the boat sailed on 6 kilometers coming out from the port. You see it now? Now, the law of this says that whenever you draw a line out, whenever a bearing comes out from the cardinal point, anywhere the bearing stopped at, there should be a cardinal point again being constructed. Whenever a bearing comes out from the cardinal point, anywhere the line stopped at, a cardinal point should be constructed again. Now, it stops here, so another cardinal point is being drawn, in which you place your north, south, west, and east. You see it now? Now we are done with this. We've created a boat sails 6 kilometers from a port X. This is a boat. It sails out 6 kilometers in a bearing of 65 degree. 6 kilometers coming out to 65 degree. We are done with this. We said, and thereafter, 13 kilometers on a bearing of 136 degree on Y. So this is X now. So where the boat got to is called X. This is your X port. Now the boat came out from here, 65 degree. At the bearing of 65 degree, move with 6 kilometers. Now move to port Y. You see it now, this is port Y. Now they said and thereafter 13 kilometer on bearing of 136 degree on Y. That same boat came out from the port Y on a bearing of 136. Now you ask yourself, how do we get 136 from here? It's very important. When you see that our bearing from north to east is 90, we know that the bearing of 136 will not fit in here because from here to here is 90. The 136 degree will appear from east to south. From east to south, because from north to south gives us 180. So 160 is in between east and south. So our bearing comes out from here. You see it now, you don't cover it. Comes out from here, you draw it this way. You see it now. So this is thereby giving us 136 degree. You see it now. Thereafter, 13 kilometers. The boat came out. The distance is 13 kilometers, in which it came out on a bearing of 136 on Y. That is it. And I told you, anywhere your line gets to, there should be a cardinal point. Anywhere your point gets to, you should also create a cardinal point there again. Now, my line stopped here. I create another cardinal point, and I placed my north, south, you have your west, and east. That we've done the second one. Now, here comes our question. What is the distance and bearing of Z from X? Now, we've gotten our X, Y, and we call the next one our what? Z. Now, the question is, what is the distance and bearing of Z from X? What is the distance and bearing of this Z from X? Of this Z from X. First, we want to take it one after the other. First, we need to look for the distance first before the bearing. Now, let's look for the distance. What is the distance of Z from X? Now, how do we search for the distance? Already we know that from X to Y, it moves in 6 kilometers. From Y to Z, moves on 13 kilometers. But we don't know the kilometer in which it moves from this X now to this Z. We need to calculate the kilometer. In order to calculate the kilometer, first we need to close our bearings. We close it. You draw it from here. Very careful when drawing it. You set it down. We've closed it down. So we need to calculate the distance here in which it came out from of Z from this X. Now, since the distance is not given, this distance is given, this is given, but here it's not given. We call it Y. Because we are going to look for this distance here of Z from X. Now, in order to look for this, we need to look for this degree inside, because this degree will help us. There's a sign, there's a degree inside which we need to look for. The degree inside will help us to search for the distance here. Now, how do we get the degree? If you look into it very well, if you watch, we need to get a degree here. Now, how do we get this here? If you look at the bearing very well, we see that the bearing from here to here, I told you, is 180. From north to south is 180. Now, if from north to south is 180, and already we've gotten from here to here, which is 136. Now, how do we get the remaining part? If from north to south is 180 degrees, let me draw it here. It looks like this. If from here to here is 136 degrees, and already I told you from your north to your south is 180. Now, how do we get the remaining part? It's very simple. What you do, you said from here to here, which is a 180 degree, minus a 136 degree. You subtract. You take 1 here with 7. 10 minus this is 4. 7 minus this is 4. You see, here will now be 44 degree. You see it down. So we've gotten here 44 degree. Very simple. Now, have we gotten this part? We've gotten here 44. Now, we need to look for the other part of this. Now, how do we get this part? So we add all the degrees together to be able to get this distance. And how do we get this degree here? There's what we call alternate angle in an angle. If you watch, you need to look for the alternate angle of this. And when you watch, another word for alternate angle, I call it Z angle. If I don't call it alternate angle, I call it Z angle. Now, what is the Z angle to this? Now, if you watch, it looks like this. From here, coming to this part, then to this side. Have you seen it now? This is the alternate angle. So the alternate angle of this is 65. You see it? Alternate angle. Look at this. Alternate angle. So any angle you have here is the same thing to the one you have here because it's alternate to this. Now, thereby, we need to calculate all the angles here. So you say your 65 plus 44. Here you have your 9. Here you have your 10, which is 109 degree. You have your 65 plus 44, which gives you 109 degree. So here you have your 109 degree. We've added all together, and it gave us 109 degree. So having gotten this 109 degree now, with this degree here, we can be able to get the distance here. Now, how do we solve for this? How do we solve for it? We'll solve for this by introducing what we call using the cosine rule. Using cosine rule. The cosine rule will help us to get the distance of z from x. Using cosine rule, since this is what we are looking for, so you say your y square is equal to, this is your x square. X square plus, you have your z square minus your 2 times x times z times cos your y. Now, how did I get this? Let me explain. You are looking for this side. Using your cosine rule, we said this y you are looking for will be outside, which is the biggest sign of it, is outside, equal to this direction. This direction is your x direction, x squared, plus your z direction, which is z squared, minus 2 times the x and the z, cos the big y. The big y is this 109. Now, after we've gotten the formula, let's substitute. Now, we said that our x squared is 6, plus your z squared is 13 squared, minus your 2 times, what is your x? X is 6, times your z is 13, times cos 109 degree. We've substituted all this. Then having done this, we need to solve. Now, how do we solve this? Coming to this part. Now, it will be your y squared will be equal to 6 squared is 36 plus 13 squared 169. You have your minus 2 times 6 times 13 times cos 109 degree. Have you seen it now? Now, this is when you're going to make use of your calculator in solving this. Here, I have my calculator, your scientific calculator. Please, make sure you go with your scientific calculator. Because of this, the sign there, this is my scientific calculator I have here. Now, I'm going to make use of this scientific calculator. In order to look for these, am I communicating? Now, to look for these, you have your this plus this, which will give us your 205, and you have your minus, this is what I want you to do now. You have to make this to be very simple for you. This is what you do. After you've added this to give us the 205, you bring your subtraction sign down. You've seen it? Then your calculator, you use your calculator, you punch this times this times this times cos 109. You punch it once with your calculator. You say your 2 times 6 times 13 times your cos 109. You see it now. When you punch it, if you can see mine clearly, mine gave us minus 50.78. You should be in 4 figure. There's a subtraction there. You put your own subtraction again, and it will be 50.78. There's 78 there. Behind it is a round-up number. So by 78, write 79. When you punch us, you say, when you punch your own, you see minus 50.788. So I rounded up. I collected one from that 8 and added, making it 9. And when you see these two signs, I told you, whenever two signs are coming together, always separate them with minus, with a bracket. Now, you're going to have this now. You're going to have 205 minus and minus is plus 5079. You see it now? Then when you have something like this, you also add. You say 205 plus 50.79. You see it now? Which give us 255.79. And you see it now? Remember, there's a square here. Y squared. Now what should we do? We are looking for y. Remember, we are looking for y. Now, the y is having a square. What should we do? We square root both sides. This cancel out this, you have your y. And you're going to square root this using the same your calculator. To square root it in a calculator, you see this, you see the root there, the root sign there. You tap it, and it will be you punch your 255.79. When you punch it, you see it will give you 15.99. You see it now. Then approximately it will give you 16 when you approximate it. It will give you 16 kilometer. So 16 kilometer now is our what? Our distance of Z from Y. 16 kilometer. 15.99, approximately 16 kilometer. You see it now. So we've gotten our kilometer of our distance of Z from X. Let me see it now. Now we've gotten that. Now let's go to the next one. The bearing. But please do well to watch this to the end because it's very, very important. Most students do come across these questions thinking it's very hard and run away from it. Not knowing that in WAEC, it comes out every year in WAEC. You see either one or two of bearing questions when it comes out. So you don't need to run away from it. You face it. Am I communicating? Now the next one, we have the bearing. What is the bearing of Z from X? Remember we've got to the distance and now the bearing. Now how do we get the bearing of Z from X? If you watch, in order to get the bearing, if you look at this drawing here, to get it looks like this. The drawing looks like this, 65. And there's another one that this came out from here. This is the one for Z. Now we need to look for the bearing of these. To get the bearing, after you've seen the bearing of this, or the angle of this, you add the sum it together to get the total bearing of Z from X. Now you need to look for the angle here. The angle here, when you get the angle here and you sum it up, you get the total bearing of this Z from this. Now how do we get this angle here? How do we get it? Very, very important. Now look at this now. In order to get the angle, we'll be using sine rules. We'll make use of what? Sine rules in getting the angle. Remember, we've gotten this. This will help us to get this part. Now how do we get this now? In order to get the bearing, you say your y, which gave us 15.99 over the angle inside. Remember, our y already gave us 15.99. I wouldn't want to use the approximated value. I want to also make use of the real value here. So you say your y over the 109 using sine rule because we're looking for the bearing. So look for the bearing. So use sine rule. Now what is sine rule? The sine rule is this. Y over sine 109 degree. You see now? Always use the given one, the complete one. That is how you need to solve to get a complete one. There must be a complete one. That's the reason we solve for the distance first to get a complete one. So we've gotten a complete one, we've gotten an angle inside, and the next one outside. So this is complete. So we are using this over this. Now this is what we are looking for. If you watch, there is no angle here. This is the angle here that will give us the bearing of X from Z. So this will be 13. And this angle is opposite to a number outside. Or opposite to this outside. Look at it, it's opposite to 13 kilometers outside. So what do we write there? You write 13 over sine theta. Remember, the theta inside in which we're looking for. 13 over sine this. Just the same way you said 9 over sine this. That's the same way you say 13 over sine, the one inside. You see, this will help us. Now, already we've gotten our y. What is the y? You said that our y is 15.99 over sine 109 degree equals to 13 over sine theta. Now, what's the next thing? You said 15.99 over, what is our sine? Using the same calculator. Sine 109. What's the meaning of sine 109? Sine 109 give us 0.9455. You see it? Equal to 13 over sine theta. Remember, our aim of doing this is for us to get our bearing. This will give us the bearing. Now, what should be the next thing? We cross multiply. We say 15.99 times sine theta will give us 15.99 sine theta. Then equal to 13 times 0.945. You point your calculator. 0.9455 times 13 will give us your 12.2915. You see your calculator. Now what should you do now? We need to divide both sides so that this will be known. Divide both sides by 5.99. You have your 15.99. Then when this cancel out this, you have your sine theta equal to. Now let's divide this through. That's what it gives to us. You divide. So your 12.2915 divided by 15.99. You see now, it will give us 0.7686. That will give us 0.7686. Now, we are looking for this. Now, how do we get the theta? Because the theta now will now give us our bearing. Now, when you come to your calculator, in order to get this, what we call shift sign, inverse of sign. Now, how do you get that in your calculator? Then, when you in your calculator, you check, you see your shift in the calculator. This is the shift up here. Tap your shift and your sign. It will give you an inverse. It will look like this. When you tap it, it will look like this. You see that? When you tap your shift and the sign, it will give you something like this. And when it gives it to you, you bring down the number. Now, shift sign of this number will give you 0.7686. You see that will give us 50.22. When you check, it was 50.22. So now, this 50.22 degree is the one we got here. You see it now? So here now will be 50.22 degree. Now, what is the bearing of z from x? Now, since we've gotten this part and we have another one here, now the bearing of z from x, we need to add from here. Now, let me use it to redraw it so that you understand fully what I'm trying to say. Now it looks like this now. It looks like this. It looks like this. It looks like this. From here is your 65. Now, from here now we've gotten is of 50.22. Now, to get the total bearing now, you add from this 65 to the line that is touching, but this line is the line that touches your z. So you add 65 plus that 50.22. 65 plus 50.22 will give us our total bearing. Now you say the total bearing, you say the bearing of z from x is equal to, you have your 65 plus 50.22. You see it now? And when you add it to the 65.00, you have your 50.22. You see it now? You have your 22, you have your 5, you have your 11. You see it now? So our bearing here is equal to 115.22. That's it. That is the answer. Thank you.